Hello, today's lesson is 4.3. It is in your Big Ideas math textbook. And before we go on to today's lesson, I just want to review what we've been learning so far in the chapter. And so I want you to pause the video and see if you can figure out the area formula for each of the polygons that we've already gone over. There's a rectangle, a parallelogram, and a triangle. And then under the reasoning, it's more like, well, why is the formula that we use? So I'm going to start off with area equals length times width, area equals base times height, and area equals 1/2 base height. Okay, so I'm going to say for a rectangle that I could use the area model as my reasoning, and I could think about the fact that there are W rows of length L. So that's why it's the product of L and W. And then a parallelogram, you might remember that a parallelogram can be turned into a rectangle, or a rectangle can be turned into a parallelogram. So parallelogram can be turned into a rectangle. And then I'm going to say where the base of the parallelogram equals the length of the rectangle, and the height of the parallelogram equals the width of the rectangle. And then the last one, of course, is a triangle, which is half of a rectangle or a parallelogram. So that's why we take the formula for area of a rectangle and multiply it by half. So I'm writing as my reasoning, a triangle is 1/2 of a rectangle or parallelogram. Okay. So now here's what we've done, right? The rectangle is area equals length times width. A parallelogram is area equals base times height. A triangle is area equals base times height divided by 2. And today we're going to look at a trapezoid. Okay, so first of all, I want you to remember that a trapezoid is a quadrilateral, right? It has 4 sides, but there's only one pair of parallel sides. And so when I look for the parallel sides, I'm drawing a little arrow, right? Because these 2 sides will never touch, but the opposite sides, right? So if I try to extend this line and I try to extend the other line, oops, that's a little wavy, but you're going to see that if these were straight lines, eventually they would intersect. That means that it's not a parallel, they're not 2 parallel sides. So I'm going to go ahead and clear all of those. So these were the 2 sides that are parallel, right? And I can just go through and I can go, okay, so these sides are parallel because I can see that if I extended these, they would intersect. Same thing with these. If I extended them, they would intersect, which means they're not parallel. So I'm going to go ahead and erase that one and that one. Okay, that means these are the parallel sides. And for this one, I have the top and the bottom are parallel sides, and then the left and the right are parallel. So it's important that you be able to pick out the 2 parallel sides in a trapezoid. All right, next. So now what I want to show you is, oops, I'm going to change the base. Okay, so I have to fix the formula, the picture that you're seeing, because the bases, we use a lowercase b for the base 1, and then there's a base 2. So the idea is that the 2 bases are the sides that are parallel. So I'm going to go ahead and put the arrows there. Those are the 2 bases. And then the height, just like everything else, the height is perpendicular to the bases. And it's also, you can see here, the height is the distance between the 2 bases because it goes from the top to the bottom, just like the height has been for triangles and parallelograms, goes from the top to the bottom. Okay, so next, here's an activity that you can do in the Record and Practice Journal. It's on page 85. And I'll show you the picture on the next page of what I did. But basically, I'm drawing a trapezoid. And I'm going to give you some instructions. And the idea is that I want you to have 2 identical trapezoids. So here it is, right, where it says you're going to have 2 identical trapezoids. you take a piece of graphing paper, fold it in half, and draw a trapezoid that you can cut out. So here are the instructions, right? Fold a piece of graphing paper in half. I'm going to ask you to use a pencil to make 4 dots. So a lot of people don't have practice drawing trapezoids. So if you don't, you can first draw a rectangle. But then what I want you to do is I want you to extend the bottom base, right? The bottom of the trapezoid. So the idea is you're doing 4 dots like this as a rectangle, but then I want you to extend the left side, the right side and the left side, and then you would connect those outside dots. Now they don't have to be extended the same amount. That's the idea of how you would draw a trapezoid. And so I'm going to show you when I drew a trapezoid, right? Here's my trapezoid, there's a fold. And then when I cut it out and I put the 2 pieces together, whoa, this is a weird thing. When I put the 2 sides together, I have a 6-sided figure. So this was a hexagon, but it's irregular. And then when I put the top edges together, I made something that looks like this, right? Which is also technically a hexagon, but it looks like a butterfly. And then what I really want to do is I want to cut out my trapezoid. And I want to take this, take the duplicate trapezoid and turn it upside down and put those 2 sides together to make a parallelogram. Okay, so now I'll show you on the next slide what it looks like. So here is my trapezoid, right? So I'm going to take my trapezoid and now I have a duplicate trapezoid. And then what I can do with this trapezoid is I can spin it around. Ooh, check it out. The height still stays the same. And then I'm going to move it over. How cool. Now what I've made is, hopefully you can see the outside of a shape is a parallelogram. But wait a minute, you already know how to find the area of a parallelogram. It's just base times height. But this is where it gets a little weird, because now the height, well, that's still h, right? It hasn't gotten any taller, but it's gotten longer. So now it turns out the base, or the bottom, has 2 numbers added together. So this whole distance across is B1 plus B2, right? That's the distance on the bottom now of my parallelogram. And this is still the h, right? So you know to find the area of a parallelogram, you take the base and you multiply by the height. But now it's just a little confusing because the base, when I duplicated my trapezoid, it turns out that the base all the way across the parallelogram is now the top and the bottom added together. So I'm just going to do that again. I'm going to grab this trapezoid and I duplicated it. And then when I turn it, oops, let's do that. When I turn it, right, come on, I'm going to spin it around. It's not working very well right now. Okay, I'm going to spin it around, and now I've made 1 parallelogram, and notice that the distance all the way across was the B1 plus the B2. So I don't have to duplicate it every time, right? Once I understand this is the process, then I could just look at 1 trapezoid and know that I'm going to be adding this plus this to make the whole distance across. Okay, let's take a look at the formula. This is what I want you to write down in your graphing notebook, right? The area is the formula for the area of a trapezoid. And notice there's 3 pieces of information you need. You need base 1, base 2, and the height. So go ahead and pause the video and write that down. Next, I'm asking you to write the steps for finding the area of a trapezoid. So you write down the 3 important values that we need. And then that's A. And then B is write down the formula. C is substitute in the values. And the last thing is, of course, do the math. So I'm going to point out there's a whole lot of numbers on this. You have to be smart, right? You have to, not smart, you have to be strategic, right? I don't want to just put in some random numbers. I want to look at this trapezoid and find the 2 parallel sides. Once I've done that, I can call this B1 and I can call this B2, right? That's what I needed to do. Oh, and then the height from top to bottom is right there. That's my H. Guess what? 6 is a slant. I don't need it. 7 is a slant. I don't need it. So the height is 4, and I'm just going to put U for units. B1 is 20 units. B2 is 10 units. Now I wrote down the formula. I'm going to substitute in my numbers. So this is 20 plus 10. So now, oops, let's go ahead and put in the units. And so now I've got 1/2 times 4 units times 30 units. And then when I do half of 4, I get 2 units times 30 units equals 2 times 30 is 60. U times U is U squared. I get 60 units squared. All right, it's pretty easy, right? Okay, so you're going to try these two on your own, and then that'll be it. So I'm going to go ahead and label the two parallel sides, and I'm going to call this B1, and I'm going to call this B2. Now you're going to see, because I'm adding B1 and B2, it doesn't really matter which I call B1 and B2, but it totally matters that the height is the distance between the two bases. And then when I look at this example, I can see that my H is 6. I'm going to call this B1 and this B2. So I write the formula. Right, area equals 1/2 times H times B1 plus B2. Okay, so I got 1/2, and the H is 5 millimeters. B1 is 8 millimeters, plus B2 is 4 millimeters. I'm going to add the parentheses first, right? Order of operations. I get 5 millimeters times 12 millimeters. Okay, now here's the thing. I could move the 12 next to the 1/2 and use the commutative property, because it's easier for me to multiply 1/2 of 12 than it is 1/2 of 5. So I'm going to go ahead and move this over here, and I'm going to continue my work here with an equals 1/2. Now I have 12 millimeters and then 5 millimeters. And 1/2 of 12 is 6 millimeters, and 5 millimeters gives me a total of 30 millimeters squared. All right, and the last one, again, I'm just following the steps that you wrote down. 1/2, A equals 1/2 H times B1 plus B2. Okay, I already have all of my dimensions labeled, so it makes my job easier. So I have 1/2 times 6 inches times 7.7 inches plus 2.3 inches. I'm going to do the parentheses first, so I'm going to get equals 1/2 6 inches times 7.3 and 7.7 and 2.3 is 10 inches, and then 1/2 of 6 is 3 inches, so I wind up with, hey, that's the same area as the other shape. 3 inches times 10 inches is 30. Inches times inches is inches squared. Oh, how cool. Different dimensions, but they have the same area. That's how you find the area of a trapezoid.